Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge, minimum time visiting all points. So basically what this problem is that we have n points with integer coordinates, x and y. And the goal is basically to return the minimum time in seconds that it will take us to visit all the points we have in the same order that they are in the array. This is a very important piece of the problem. You don't need to find like an optimal ordering. You just need to find the minimal time it could take us to traverse in the same order that we have them in the array. Okay, so that's very important. So we shouldn't think about sorting, because if we do it, then we will not respect the original order in the array. Now, since we are asked to find the minimum time in seconds, right? So what is a second here? The problem says you can move in 3 ways, like this, and each one of these takes 1 second. So each of them is 1 second. This one is 1 second, diagonal is 1 second, and then horizontal is also 1 second, okay? The way we did to get from this one to this one, it will not affect, right, the way we will get from this one to this one. They are completely independent, right? So that means basically what we can do is just think about how do we optimize the path between a point and the next one, just between 2 points. Once we do that, we can apply it for every adjacent point and just get the total, right? So that's the first insight. Now, the second thing to think about is now the problem for us is just what is the optimal the optimal strategy we can do to get from one point to the other. And the first thing to think about is the rules that we are given. We are given that you can move horizontally with 1 second, vertically with 1 second, and then diagonally with 1 second. Okay. Now, one thing you will notice is that moving diagonally is always better if you are able to. What do I mean by that? I mean, let's say, for example, you have 1 point maybe is here. Let's say our P1 is here. Let's say this is our P1. And let's say our P2 will just take some other points, maybe 3. Let's take 4, 3, for example, this one. 4, 3 here, right? Yep, 4, 3. So what's the optimal way? Well, the right way to do it is, because it's always better for us to do this diagonal, because if you do first horizontal and then vertical, then that's 2 seconds. But here it's just 1, so it's better to use the diagonal. Okay. Now the question is, in what case it's not better to do the diagonal? So, and then here we do the diagonal again. Okay, so now we have 2 seconds. Now the question is it better to continue with the diagonal like this, or is it better to just do vertically, right, like this in the orange color? Well, if we do continue diagonally, then we can't keep continuing diagonally, because then we will go like further from the point. But we can do diagonally first and then do after that do horizontally, right? But the problem, this is 2 steps, this would be 3, 4. But doing it vertically here is just 1 step 3. So now we need to find, well, what's the difference here? Why in this case it was optimal to do diagonally, but in this case it was optimal to do vertically? Well, the answer you need to think about and just notice from the pattern here is that because the target point, let's call it, and let's say this is the source point, the target point shares the same coordinates, y coordinates, with the point we are at where we decide to go vertically, right? If it shares if it shares x or y, then it's better to do vertical. So at least we know is if it shares a y, it's better to do vertically. Because if you do diagonally, then you would have to come back horizontally. Now let's try to do the same thing with points where we need to go horizontally. So let's say maybe 0, 4. So it needs to be here. And so if we go diagonally, we'll go like this, and then go like this, and then have to do horizontally. So again, you can see here, it shares the x coordinates. That's why we did the horizontally, because if you continue diagonally, then you would have to come back like this, right? And so that's in this case as well, when it shares the x coordinates, we move horizontally. We have 2 steps each time. What are the 2 steps? Well, the first step is that we continue going diagonally. So step 1, diagonal movement, right? And then step 2 is either horizontal or vertical. So let's break sort of the number of seconds into these 2. So for step 1, how much is the total? Well, for step 1, it's just the max between, it's just the mean between the 2, right? Because let's say we have a point here, and then we have a point here. So the diff 1, 2, actually the point needs to be here for it to be valid. So the point is here, right? So what is the x and what is the y difference? So the x is 1, 2, the y is 2, okay? And the diagonal is 2. So the diagonal is equal. So let's take one where it's smaller. One of them is smaller. So this is 1. And let's say the other point is here. So what is the diagonal? So the diagonal we can traverse is only this one, because if you go like this, you will go past the point. Okay? And so the only diagonal we can traverse in step 1 in that case is 1. Now what is this one? The 1 is just the minimum of the 2. And that same thing applies if we take, let's say, one where the horizontal part is larger. So let's say 2, 3, and then the vertical one, let's say, is just 1. Well, the only diagonal we can take is like this in step 1, because we stop when the x coordinate is the same. And so what is this? This is also just the min, because this is 3, this is 1, we just take the min. Okay, so step 1, always what we can take is only the min between the 2. So it's the min between delta for x and the delta for y. That's the value from step 1. Okay, now, okay, so what is this 2 in that case? The maximum, 3 minus 1, is just the maximum of the delta x and delta of y minus the minimum. Because the minimum, we already used it for the diagonal, right? And then you go vertically to the point that you want, okay? And so in this case also, what is the difference? Well, this one was already done by the diagonal, and so we just need the remaining part, which is just 1. So what is also, in this case, what is the remaining part? Well, the remaining part is the total, so it's just the max of delta of the 2 minus the min, means that step 2 is just the max of delta x, delta y, minus what we already traversed with the diagonal, which is the min of delta x and delta y. And so if you add these 2 together, this one gets cancelled by this one, and the remaining part is this one. And so no matter what the points are, right? No matter what the points are, this would be the results. Now let's show that it actually works when we don't need a horizontal or vertical. So in that case, well, it's just the max between the 2, so that's 2. So in all cases, we can just use this formula to get the distance the minimum number of seconds we need between 2 points, and we can do it for every adjacent 2 points and get the total, and that's pretty much it, right? And this can be done in OVN time. We just need to go through the points. So for that, we need the length of the points, and we need just something to add up our result. And so let's call that 0. Let's call that seconds, actually. And this is what we need to return at the end. Now we start from 1, because we'll compare each I with I minus 1. Okay, and so basically to get the delta, what we need is just the delta between the x's. And so what are the points we are dealing with? Well, point I and then I minus 1. So let's call this one x1 and x2 and y1, sorry, and this one x2 and y2. And so what we said is the number of seconds is just the max between the difference of both. So of course we need to take the absolute value because it's all distances no matter the direction you are in. So x1, y1, x1, x2, delta of x, and then this is minus because this is the delta, and then the delta between y1 and y2. Okay, and that's all we need to do. So let's run this and let's submit, and this passes. Thanks for watching, and if you need help one-on-one, reach out to me via Superpeer, and see you on the next one. Bye.